The story of science, changing man's way of life in our time. The principle of magnetism and uses for the magnet have played a part in man's welfare for centuries. Today, science is developing powerful superconducting magnets whose coils, immersed in liquid helium and cooled to a temperature of 450 degrees below 0 Fahrenheit, can set up a magnetic force which is 130,000 times more powerful than the pull of Earth's gravity. Today, super-strength magnets can turn men upside down and make it possible for them to walk under steel beams. Wearing shoes with permanent magnet soles that require no electric current, the man at will can switch a brief electric current to either shoe. Momentarily demagnetized, the shoe is released from the beam, allowing the man to take an upside-down step by reclamping the shoe to the beam farther along his route. After viewing a magnet that turns men upside down, a magnet which only turns a small safety pin upside down may not seem impressive. However, this demonstration has, so to speak, its point. All of these small metal objects have one thing in common. They were swallowed by children. Dr. Arthur Penta, a specialist practicing in Schenectady, New York, recently asked General Electric's research laboratory to develop a magnetic tool that could retrieve swallowed metal objects from the stomach or esophagus of a child. Their answer was a device built around a small, powerful magnet. The magnetic device can be switched on or off by manipulating a control cable with a flick of a finger. When the device nears a metal object and is switched on, the object leaps to the magnetized tip. A sharp or pointed object may adhere to an ordinary magnet in a position that could dangerously puncture delicate tissues during withdrawal. The new device eliminates this possibility. The magnet remains switched off until it is positioned to withdraw the pointed object harmlessly. Here, Dr. Penta has a young patient who is suspected of having swallowed a bobby pin. The doctor's X-ray verifies the suspicion, and at the same time, it locates the exact position of the bobby pin. The next step is to retrieve the bobby pin with a new medical instrument, a simple procedure that requires no anesthesia. As Dr. Penta manipulates the device, its path is followed on a fluoroscope by another physician whose instructions help the doctor make proper contact with the swallowed bobby pin. The fluoroscope shows that contact was made on the tip of the bobby pin before the device was switched on. And the bobby pin comes up and out, the procedure taking about 3 minutes. After centuries, magnets continue to attract metal objects and the imagination of scientists, this time on behalf of endangered children. Another type of medical emergency involving children is the special concern of Dr. Henry West of Pittsburgh, who specializes in the diagnosis and treatment of poisons. Dr. West has compiled a comprehensive list of poisons and potentially poisonous substances and a library dealing exclusively with this general subject, including a handbook of poisoning. Reported poisonings require time to research and classify symptoms and determine the antidotes. This time lag can mean life or death for a stricken child. Dr. West also employs electronics to eliminate this critical time lag at his Poison Information and Treatment Center at St. John's General Hospital. Other hospitals have adopted the doctor's system. Reports of poisonings are telephoned to Dr. West and are then turned over to his electronic correlator. The correlator is a computer which has been programmed to remember all known toxic substances, the symptoms produced by them, and the parts of the body affected. Each symptom has its own light and number positioned on the electronic board beside the name of the substance producing the symptom. As the appropriate buttons are pressed, the lights indicate the probable toxic agent and the dosages which are fatal to adults and children. The electronic correlator, another computer partnership with medical science in the race against time when a child is poisoned. Of the ills that befall children, one of the most distressing is called strabismus, a condition in which the two eyes do not look at the same object at the same time. The eyes fail to combine their separate images to achieve the stereoptic vision of normal eyesight. In a doctor's office, two mothers quietly discuss the unhappy effects of this affliction upon their children. In the children's presence, they choose words carefully, but they cannot avoid the word cross-eyed, as the children cannot avoid the cruel taunts and jokes of other young children. The mothers realize that in addition to a visual handicap, lifelong psychological scars and adult social embarrassment may confront their cross-eyed children. In nearby Palm Springs this morning, another discussion on the difficulties of strabismus. The first International Congress of Ophthalmology is attended by over 200 medical specialists from Europe and South America, Mexico, Canada, and the United States. In this setting, the words also are carefully spoken, not for humane reasons, but to express with exactitude the problems and even the controversies that arise when a disease continues to frustrate the best efforts of medical science. The problem in strabismus is that the doctors must treat through surgery or corrective techniques the eye muscle, the end organs, whereas the affliction originates in the nerve impulses of the brain. Secondly, the best chance for complete correction by present methods is when the child is in early infancy, an age when most parents are unaware of the defect or unready to submit the child to treatment. Strabismus is not rare. 3% of the world's children are its victims in one form or another. And so the International Assembly of Doctors is highly attentive at this symposium. Many of them tape record every word uttered from the platform. Vietti of Rome addresses his colleagues on the status of orthoptics, the exercise of optical muscles with prisms. Sertucha of Mexico City speaks of the A and B syndromes. Ruderman of Detroit discusses the convergence relationship of the eyes. Villaseca of Santiago presents a paper on the results of horizontal muscle surgery. Von Noorden of Baltimore comments on the pathology of eccentric fixation. Aruga of Barcelona discusses the treatment of overcorrection. It cannot be reported that the first International Congress of Ophthalmology in a single spectacular stroke defeated strabismus. Mothers will continue to speak the word cross-eyed in hushed voices, and children will continue to suffer scorn and laughter. Doctors will continue to treat the victims of strabismus to the best of their increasing knowledge, for the science of medicine surrenders to nothing. To a passerby, this artificial body of water near Berkeley, California, resembles a community swimming pool. It is not a swimming pool. It is a shallow outdoor pond on a campus of the University of California. This pond may one day be known as the world's most important body of water, occupying less than an acre. It may well mark the start of a new kind of agriculture, an agriculture especially promising for countries that lack rich soil and abundant water. The pond is full of raw sewage and wastes piped in from a small city nearby. This is what normally happens in sewage water. First, the natural bacteria attack and decompose every bit of organic material. The new bacterial substance is then absorbed by single-cell plant organisms called algae. The millions of algae grow and multiply at a rapid rate. As microscopic plants, they also absorb sunlight, and through the process of photosynthesis, the algae convert the sunlight and bacterial elements into food energy, at the same time giving off oxygen. Eventually, the algae also die and sink to the bottom, becoming part of a thick sludge, 50 times richer in protein than is produced from an acre of wheat. If the water is drained from the pond, the sludge may be gathered by a simple method and dried in the sun by a simple method. The coagulated algae plant material is now a rich nutrient that can be sterilized and fed to animals. The University of California's experimental pond employs mechanical techniques to harvest the algae, not to alter the natural process, but to speed it. Filters and drains are used to separate inorganic wastes from the natural sewage upon which bacteria thrive. Pumping equipment is used to activate the water so that bacterial elements are stirred together with the living algae instead of settling to the bottom. The thick surface layer of algae organisms are harvested by drainage from the pond's surface instead of by emptying the pond. Separation of the sludge is by centrifuge, and drying is by steam rather than sunshine. The steam simultaneously sterilizes the algae of possible disease-carrying elements. The result, a protein-rich concentration of animal food. In dry granular form, it may be stored indefinitely without refrigeration. Its odor is similar to that of fresh alfalfa hay. The algae is so rich in vegetable protein, it is best mixed with cheap carbohydrate grains for feeding to domestic livestock. The scientists are investigating animal acceptance of algae as food. While goats are not particular about their diet, the fact that they love algae may be of interest to populations which raise goats for their meat, hair, and milk. The meat of lambs which were fed with algae was excellent in quality and taste. Not all countries have the soil and water to produce rich protein, but every country has algae-producing sewage. Is science about to give the world a rich new harvest?